Alright, we've talked about radicals, and now we're going to talk about them, or square roots sometimes you guys call them, but I like to call them radicals. Anything with the symbol there is a radical, okay? It's something that is used to multiply itself to make the whole. So we're going to talk about adding radicals today. So I have the square root of 5 plus 3 square root of 5, and I want you to see that just like x plus 3x. You know, so it's like, yo, I got a square root of 5. And then I bring in 3 more square roots of 5. So how many square roots of 5 do I have in my pile? Well, you think about it, it's just like x. I have 1x, I add 3 x's, now I have 4 x's. But let's be clear that we can do a double check here too. Because calculators are a great tool. So if I use my calculator, and I'll start here on the left actually, before I do the calculator work. Square root of 5 plus 3 square root of 5. Let x equal the square root of 5. So this is x and this is x. So I can write that as x plus 3x. Which through all our practice with like terms, those are cats, both of them are cats. Siamese, perfectly the same. We add them, we get 4x. So if we let x equal square root of 5, we can put the square root of 5, so 4 square roots of 5. How do I know I'm right? Well, I can use my calculator. Handy dandy. Old TI-33. And I can use the square root key. Alright, and I can put in square root of 5 and get the decimal value. And I can do the math, order of operation. And if I do that, you'll notice it is the same value. And it would have to be, right? Because we're not allowed to change the value of expressions. This is an expression, no equal sign. 2 terms to 1 though. So, when I look at square root of 2 plus square root of 3, it is simplified, it's already done. They're unlike terms, cats and dogs. Do not get a single term. That would be bad. And if you want to see why, you should see that square root of 2 plus square root of 3 is approximately 3.146. Anything else, the common errors, aren't even close to 3.14. So again, order of operations, making sure the expression maintains the same value. So let's do some practice. Again, we look at these and we say, are they like terms? This is 4 times square root of 2. Take away 5 square roots of 2, add 7 square roots of 2. All the same. If I add them first, 4 plus 7 is 11. 11 minus 5 would be 6 square roots of 2. I'll do it in a different order. I'll do left to right. 4 minus square root of 5 is negative 1 square roots of 2. Negative 1 plus 7 is 6 square roots of 2. Awesome. So I look at the problem on the right side. And again, what are like terms? Do we have cats? Do we have cats and dogs? Do we have just dogs? I think it's a cat and dog problem. We have 2 terms. We have the square root of 3, and then we got the square root of 2, just like the math teacher has no friends hanging out. So I will tell you right away, 5 square roots of 2 is part of the answer. I need to combine these two. 6 square roots of 3 plus 2 square roots of 3, those are like terms. If you like, you can put them next to each other. And some teachers teach it this way. They say, hey, you see this? We can bring out the square root of 3. We could factor, you know, reverse, distribute. Okay, fine, greatest common factor. But either way, I don't typically do it this way. I usually say, hey, we got 6 and 2, and that is 8 square roots of 3. Not that this method is wrong, it's just a lot of extra steps. So now, 2 more boards. You can pause me and try them, or watch me do them. They're bigger, a little longer. Alright, negative 3 square roots of 2 plus 7 square roots of 3 plus 8 square roots of 2 minus 5 square roots of 3 minus 6 times the square root of 3. Find my cats and dogs. Pause me if you want to try it yourself. Negative 3 plus 8 is 5 square roots of 2 plus 7 minus 5 is 2. 2 minus 4 is negative 4 square roots of 3. Again, this is the cat, this is the dog. Like terms, just using the coefficients. X's and Y's is all they can be thought of. Last one. Alright. 6 square roots of 7 minus 4 square roots of 3 plus 9 minus 5 square roots of 3. So let's take a look at it. Alright, what's the same? Just these two. Alright, the other two aren't the same. They're different. So this one's this and this one's that. Those are nothing. Now often we write the whole number first. We discriminate. Positive 9. Then I'll write 6 square roots of 7. Negative 4 and negative 5. If you think about it, they're both to the left. Negative 9 square roots of 3. How would this problem change? Last thing we're going to do today. If I did this at the end. The way this problem changes if I do that last step in red is you have to do multiplication first. And remember from square roots, square root of 7 times the square root of 7 makes the whole 7. And now we have like terms again. We have 9 and 7, which I can write as 16. And so again, we got to keep all these rules in mind. And again, if you type this into a calculator to get an expression, the value here has to be the same. Track your values is a great way to double check. Keep practicing.